radicals today. It's a radical topic, right? It's like really rad, man. Right? Okay. But do you guys know what radicals are?
No, babies.
What do you think they are?
I don't know. It'll come to mind once you like.
Jerry, why don't you just like do a problem
It's
first?
a slang word from the 80s.
Radical, bruh.
I think I remember this.
Dude.
Well,
I drew occupants with a top hat.
Everything
I
is
have
from
one.
the
Oh,
80s.
that's
okay, guys, just a reminder, this is a video and it's recording. Square roots are radicals.
Oh, where'd my pencil go?
Wait, I have this whole thing about what radicals are.
What's a square root?
I think I took.
Oh yeah, I remember this.
Like square root of 4, right?
Oh yeah.
Cube roots, guys, let's have it quiet now. Cube roots are also radicals.
It's like Minecraft.
I know, right? It's like I'm mining for trees.
4th roots and 5th roots and 6th roots. Now, and we're going to talk about that. But a cube root would be like this. It would be this, say, like of let's just say 27. And notice I have to, if I'm talking cubed roots, I have to put a little 3 right here. Okay? And we're going to talk about that.
Oh, that's
In square roots, I don't have to put anything here, but there is something hidden here, right here. And it's a 2, right? There's a little 2 there. And if you don't have the 2, it's automatically assumed it's a square root, right? It's not a cube root. Okay? You can have 4th roots. You can have this, right? 4th roots. 2 times 2 times 2 times 16. 4th root of 16 is 2, right? 2 times 2 times 2 times 2 is 16. I need 4 2's, right? Here I need 2 numbers that add up, that multiply to get 4.
2, 2.
So let's just talk about what a square root sign means. A square root sign means this.
X times X.
What number times itself equals
Gary, stop saying
what number times itself equals the number under the radical sign?
It's a radical sign? I thought it was like a square root thing.
Yes.
Yeah, square root.
Well,
Radical is okay, can we call it the square root thing on a test?
I
Yes.
want to call it the radical because like
number
this thing
times
is so
itself
But-
equals like
radical.
Yeah, you guys are not, you're familiar with square roots, but you're not familiar with this actual terminology. And you have to get used to it. Radicals are square roots or cube roots or those kind of things. So the question is, why do we have to have a different name for things? Well, radical is like the big umbrella topic that encompasses all the types of roots, right? Square roots, cubed roots, 4th roots, 5th roots, 6th roots, right? And so square roots, if we just talked square roots, we wouldn't be talking cube roots, right? Cube roots and square roots are different things, but they're both radicals. Just like, well, you know, like, well, what's an example?
Gary, stop saying oh.
I can't think of an example. That's
Gary,
okay.
like,
I'm not
his
gonna,
pen for a
okay,
whole
you guys are making me confused because I'm saying too many times. Okay, so then if we take this definition and we put something inside it, inside the square, this is not working very well. Let me just try this color.
Like the blue.
The square root of, say, 16. Okay, so what number times itself equals 16? 4, right? 4 times 4. Now I'm going to write it that way first. I'm going to write 4 times 4. Okay? Instead of writing the answer yet. Okay?
Well, why do you do it?
Because I want you to see something first. Okay? And this is a square root because it doesn't have anything here. So I know it says it's got a square, a 2 in here, right? A hidden 2 in here. And what that 2 says is I need 2 of the same number multiplied times each other before I can bring them out. Notice I have two 4s here, right? I can cross those two out and they come outside as, I can cross those two out and they can come outside the radical sign as one of them. I like to sometimes do it this way where I just put anything that comes outside, I put it above for now. Just so, because this is simple, it can start to get more complicated soon. So because there might be more than one groups of two, right? And so then I put them there. And then, so my final answer is 4. And notice there's nothing left inside the radical sign, right? There's nothing else in there. Therefore, I don't have to write radical sign. There's nothing to keep in there, so I don't need it. Yes?
So do you want us to do all of that on the homework?
No, I'm explaining the theory behind it first, right? Most of us are going to go square root of 16 is 4. Square root of 25 is 5. Square root of 81 is
9.
9. Square root of 100 is
10.
square root of 144 is
12.
12, right? You guys know that. You guys know that. The reason I'm going into this detail, you'll see why in just a few minutes, because what's the square root of 12?
6. No, 4, 3, 8. What?
There is none.
Wait, could you break it up into 2? Like,
Square root of
So
6 and
you're
2.
realizing, well, wait a minute. 2 times 2 is 4. 3 times 3 is 9. Oh, it's got to be above 3, but 4 times 4 is 16. It's got to be below 4. You see what I'm saying?
It's
So-
pi.
So,
3.1.
well, it's probably close to that. But it's
Yeah,
not,
I
it's
got
not
it right.
that. It's not that. But,
See?
so what if I did this though? What if I said the cubed root of 8? Cubed root of 8.
2.
2. Or no.
Yeah, 2 times 2 is
So it means I need 3 of the same number to multiply times each other to get 8. 2 times 2 is 4 times 2 is 8. So you're right. So it would be, like, I'm going to do it the long way first. 2 times 2 times 2. It says I need 3 of the same number, right? That's what that says. I need 3 of the same number multiplied in order to cross them out and bring them outside. So therefore the answer is 2, right?
Oh my god, it's 2.
Now what if I said this?
Yeah, 4.
What if I said,
Cubed root of 21.
what if I said the cubed root of 16? What if I said the cubed root of 16? So, Manu, you should be taking notes. Everything on the board should be on your notes.
Oh, that's wait, not 3.
So, it's hard to know, right? So, what if I did this? What if I said, well, I know 16 is 8 times 2, right? And I know 8 is 2 times 2 times 2, right? And then times 2 more would be 16, am I right? Do you guys see it? 2 times 2 is 4, times another 2 is 8, times another 2 would be 16, right? So I could write it, I could actually simplify it into its prime numbers.
But-
Now look, it says 3 of them. Okay, what's the question?
Couldn't you like just put the answer as like an exponent of like 2 to the 4th power?
Not in this case, because it's asking for cube root. It's asking for cube root. So think about, I'm just showing you this little trick, right? This says I need 3 of the same numbers multiplied times each other to take them out. So I'm going to take those 3 out. I don't have 3 more 2's though. I only have 1 2. So my final answer will be the one that's out, 2 in front, and then the cubed root of 2, because that's what's left over. See what I'm saying? You start to see that?
No.
You're going to see that. You're going to see it more in a second.
Is it
We're
okay
not
if
going to be
it's
dealing with cubed roots
Oh,
that
that
much.
makes sense.
It's
Because
totally
2
okay
times
for the answer
the cube root of 2.
if you simplified it as much as you can.
Say it one more time.
It's totally like capiche to leave something in the cubed root if you simplified it as much as reasonable.
Yes. Yes, okay. So we're not going to, so I just wanted you to see this, but we're not going to do a lot of cubed roots right now. What we're going to focus on today is square roots, okay? But I just wanted you to understand that that number in front of a radical, or in that little space in a radical, It's saying you need two of the same things or three of the same numbers multiplied times each other before they can come out, okay? That's a useful piece of information. Oh, I have my, can I erase this?
Yeah.
So, can I erase this too? Can I erase
You're
this
already
too?
doing it, so. Gary, you should tell us a joke while you're erasing.
Okay.
Yeah.
So, let's just first go with ones we know. We know the square root of 1. What is the square root of 1?
What?
1. 1 times 1 is 1. What's the square root of 4?
2.
2. What's the square root of 9?
3.
What's the square root of 16?
Wait, slow down.
What's the square root of 25?
5.
What's the square root of 36?
Gary, slow down.
6.
Okay, I'm going too fast.
Yes, because you know what you're going to write and we don't.
Is that one?
I don't like any of my markers. I have to buy more.
You can use your Sharpie.
I think you're
Right.
right.
And I will use Sharpies on whiteboard.
What
I
is the
know, they work
square
so
root
well.
of 49?
That's 7.
What's the square root of 64?
8.
Okay? And I can keep going. Square root of 81.
Is someone calling you, Gary?
What? What?
Someone calling you? It's coming from out there.
That's not my phone. Why is there music? Can you just close that door? Can you peek out there and tell me what's happening?
It sounds like a horror film.
It does.
No, guys, have a seat. So
They said nothing.
who's they?
It's graders.
Okay,
People sit
okay,
on the couch.
okay, come on, Dee Dee, come on, it's my class, it's my video.
Turn off the door.
It said it was in the back.
You should edit your videos, Gary.
I know.
Okay, guys, so Dee Dee, have a seat. All right.
Put
So these are really easy, right? These are really easy. Everybody's been exposed to these, right? Everybody's been taught these, am I right? Is there anybody that's not been taught? You've never been taught these?
But I know them.
Do they make sense though?
Yeah.
2 times 2 is 4.
Yeah.
3 times 3 is 9. 4 times 4 is 16.
Yeah.
5 times 5 is 25. 6 times 6 is 36,
Yeah.
so forth, right? So those are what radicals are, or square roots,
Is
okay?
that what our homework is?
Sort of.
Easy.
Yeah,
1, 2,
that
3, 4,
part,
5,
that
6, 7,
part of it is, right? But then, what if I gave you, so this is where we need to start paying attention, okay? This is the part. If I gave you the square root of 12, and I asked you to simplify the square root of 12, there is not a perfect square root of that. There is, when I was a kid, we didn't have calculators. Did I tell you the story?
No, they were $200.
$300. My dad, when he was 40, I was probably 12. You know, we bought him for his 40th birthday a calculator. It was one gigantic thing like this, and it added, subtracted, and multiplied and divided, and that's it. And it was $300. It was ridiculous, right?
What? How
And
old are you, Gary?
they didn't take square roots. It didn't do like all these cool things nowadays. Nowadays you can do practically anything on a calculator.
From the
But
dollar
so what, instead of having a calculator, what we did is in our textbooks, at the back of the book, they had tables upon tables.
Yeah.
The square root of 1 is equal to 1 point, whatever. The square root of 2 is equal to 1 point something. The square root of 3 is 1 point something. The square root of 4 is 2. The square root of 5 is 2 point something, and the square, you know what I mean? And it went a table after table after table. And so, and you had to use those figures, and they were never-ending, kind of going on forever kind of things, most of them, right? They were irrational numbers, right? And yes.
Let me remind you of something. We were talking about tables in the back of the book. Last year when I was in 6th grade, we had we had like these big math textbooks,
Right.
and we wrote in them. And in the back of the book, it had all the answers. And we see like a whole bunch of kids like turn to the back of the book, go over here, write the answer. Turn to the
That's how my book was. It just had
Yeah.
the odd numbers or something.
Yeah.
Yeah,
it was like
Yeah, that was my book.
And so one of my friends, he
All
like
right,
do a
so
bunch
guys,
of them, like,
guys, I'm just reminding you that I have a lecture started and a video running.
Last
So-
year, I just put the randomest answer up. The one that like C.
I do not like. So Manuk, did you not hear me? Alright, so, I don't know why I can't find good markers. Okay, so the square root of 12. The key to this is, one way to solve these is to use a tree factorization. You guys remember how to factor by trees?
Yes. I made the tree.
So, let's do it. So, if I do a tree like this, 12 is the same as 2 times 6. You guys agree with me?
yeah.
And then 6
It's a prime number, so you-
is 2 times 3. You agree with me?
Oh, yeah, I remember now.
You just
Right.
bring the other two down, right?
I hate
So
these.
12 is 2 times 6. 2 is a prime number, right? So I'm going to circle my prime number, right? And then 6 is not, that's a composite number, right? It still has other things that goes into it. So I got 2 times 3. 2 is a prime number. The only thing that goes into 2 is 1 in itself, 1 and 2. And the only thing that goes into 3 is 1 and 3. So that's a prime number. So I know that 12 is the same as 2 times 2 times 3. Agree with me? Okay, so I'm going to write that down. The square root of 2 times 2 times 3.
Oh, it would be 2 square root of 3.
Exactly. So Manuk immediately saw, oh, wait, this is square root. There's 2 of the same thing. I can cross those 2 out and bring the 2 up. And then my final answer is I've just put this in front, 2 the square root of 3.
That's
Yay, Manuk smart, everybody. Woo.
And so this is considered, good job. So this is considered the simplified version of that. Okay? So if I said simplify the square root of 12, that's what I'm looking for. Okay? So let's try a few.
that's complicated.
So let's try a few.
How does that equal 12?
How about the square root of 28? Okay, so we're going to use our tree factorization for
What
now.
times what equals 28?
All right.
Not like 4 times
7,
6
it's
or
7 and
4
4.
times 7.
4 times 7. Okay, 7 is a prime number. Do you agree with me?
Yeah.
Now 4 is not. So we got 2 times 2. Oh, but those are prime numbers, right? So then my what I put in my thing is I've got 2 times 2 times 7. 2 times 2 times 7.
There's 2 2s.
There's 2 2's, so I'm going to cross those out, put the 2 up above.
So it's 2 squared.
So it's 2 square root of 7. Piece of
Oh my
cake.
God.
Whoa.
you-
Oh my
you-
God,
Piece of
so
cake. It's
Now-
so easy,
Now what's the
right?
other problem that messed us up?
This is, it's so easy, right? It makes sense, right? So let's try another one.
Until, it's like until this problem.
No, there's no until. This is
What's 33?
32. Square root of 32.
Yeah. 8 and
Gary,
4.
there's always an answer.
Okay, 8 times 4. What about 8?
4 times 2.
Okay, 4 times 2.
Two's
Ah,
prime.
2's prime.
And
And then what
it's all
about
2 and 2.
2 and 2? That's prime, that's prime. And then this one is 2 times 2. That's prime, that's prime. Okay, so I've gotten down to, look at that, it's all 2's. That's interesting. So I've got, that's the same as the square root of 2 times 2 times 2 times 2
No.
times
Right on,
2.
Skylar.
Yeah, Skylar.
Jeez, don't be lazy.
You could do that, Skylar, but for now, let's take it one step at a time. It's a good question. You
Why
could
can't
do
you
that.
write it as that? Because that's technically simplified.
Which one did you cross out?
What?
2 to the power is technically
You
simplified.
crossed
You're just
out
gonna
all
cross
of them.
them. You're
Yeah,
just
because
gonna
you
cross
cross
them
out all of them anyway.
Well, but you have to still, the issue is, if you wrote 2 to the 5th power, that would be totally true. The only thing is, you have to have a method to take it out of the square root sign.
Yeah.
And I haven't taught you that method yet. There is a method to do that, and we're gonna learn that, but not today, okay? So I'm just showing you this method first. And I'm gonna show you a faster method to do this very soon, like today, right? But I want you to understand this method first, because if you can't remember the faster method on a test, this works always. It's so easy, right? So this is square root. It has a hidden 2 right here. I know I can only take out two twos, if I have a pair of twos, there's a pair of twos right there, right? Okay, that's going to come out as a 2.
So you can't.
Oh, wait, you noticed. Look at that, there's another pair of twos right there. I'm going to bring that out.
God,
Oh,
Gary,
can I
you're
get it?
scaring
And-
us.
And I'm going to multiply those, right? That's what's going to happen to those on the
So if
outside.
I put a 4,
But,
have
but
2
look,
and
I
8.
still have this one that doesn't have another pair. You know?
4 under the square root of 2?
So yes, it's going to be 4. 2 times 2 is 4. Square root of whatever's left over, which is your 2.
So it's like multiplying, it's like dividing in 3rd grade.
Pretty much.
Because you use
Yeah,
the
because you use the tree did you use tree factoring in 3rd grade?
Yeah.
And you have
Oh,
to
that's
do
in fourth
remainders, and I
grade.
needed remainders.
This is 4 years.
But then I got into decimals and I missed remainders.
Okay, good.
Yeah. At least
So- So let's just try another one. How about
Whiteboard marker for you.
shh, guys, square root of 48.
I don't like it.
Square root of 48. So I don't know, like 4 times 12 maybe?
Oh, I'm gonna do
4 times 12 or 6 times 8, we could have done that, it doesn't matter. You know, as long as they multiply. So 4 is 2 times 2. There's my prime numbers there. 12 is 2 times 6, there's a prime number and a 6. And then 6 is 2 times 3. Okay, so there's my prime numbers. So I know the square root of 48 is 2 times 2 times 2 times 2 times 3. Okay? All right. I see there's 2 of them.
Got it.
There's a pair there, that's a 2, that comes out as a 2. There's another pair, that comes out as a 2. I'm going to multiply those.
Yeah, I finished.
So my final answer is what?
Square root of 3.
4 square root of 3.
Oh, I'm so
Piece
sorry.
of cake, right? Piece of cake. Really easy.
Yeah, 11.
Really easy.
You have homework down
Okay.
there?
Hold on.
All right.
No, what's the easy way? What's the fast
Now,
and easy
now I'm
way?
going to show you. I'm going to show you a different.
But I don't have it on my paper.
Yeah, I don't have more
Is
room
that your
here.
last page?
I had to flip the page for that last problem. I know.
Gary,
You
can
have
we
the
just like
next-
But
don't
I
you have
do,
the-
homework
remember that's what the homework is.
So now I'm going to show you. I'm going to show you a different way to think about it. Okay, which is I use this method, but I use the method I'm about to show you more often because it's fast, okay? And if you get it down, great. If you don't get it down, that's okay. Use this method. This method always works. Nothing wrong with this method. Yes?
Could you just like give us the homework now? We have like 20 minutes to do the homework.
And ask questions.
Yeah. You can ask questions.
Yeah, come on.
Yeah, we can just like find out how we do it. and just, like, get it rolling.
Okay. So, like I said, I'm going to show you this other guys. Guys, please. So,
What was that? That you?
that's me. Okay, that's my phone.
Gary, you're a robot.
So, here's a different method. If I say finding the square root of 12, I'm going to think about all my perfect squares. And when I say a perfect square, let's think about it for a second. When I say a perfect square, I'm talking about a square, right?
So like graph paper.
And let's say that the side of the square is 2. That means every side is 2. Do you agree with me?
Yeah.
What's the area?
4.
4, right? Now, to find, if I know my area of my square, to find one of the sides of the square, all I'd have to do is take the square root of the area, and it would give me the side. Does that make sense? The square root of 4 of the area is one of the sides of the square, right? So that's what I mean. So when I say all the perfect squares, I'm talking about numbers, the areas that have perfect square roots. Does that make sense? So let's think about what those are.
Or not have perfect square root.
Now,
Maybe this
we,
is taking longer.
now we do have, well, it's taking longer because I'm explaining it. But once I explain it, you're going to realize it's really easy, right? But, so all our perfect squares would be, say, 1,
Gary, you have it on.
4,
Gary, you have
9,
it on that side.
16, 25,
Gary, you have it on the
36,
other side.
49.
And
Gary.
just before.
I know, I have them there, but I'm just showing you. When I do my method like this, in the beginning, I suggest that you write these out on your paper up in a corner. so that you have them to look at,
Wouldn't
okay?
that take longer though?
Initially, yes, okay?
Sometimes.
But, like, not if you're doing like 20 problems, then this takes like, you know, maybe 20 seconds to write these out. And it's gonna save you. So then we have 49, what's next? 64, 81, and 100. And I usually stop there. Now, most of the time, you're only gonna need like, you're not gonna use 1. Why would you not use 1?
Because one is stupid.
Because one time you want to put one.
Whoa, that is racist.
If I looked at the square root of 12 and I said, oh, yeah, but the square root of 12 is the same as the square root of 1 times 12. That doesn't really help you, right? That doesn't simplify anything,
Yeah.
right? So you're not going to use the 1. You're not going to use the 1. Guys, I feel like all of a sudden you stopped focusing. So let's focus. You're going to, most of the time you're going to use the 4, the 9, the 16, maybe the 25, maybe the 36, and occasionally you'll use these bigger numbers, but probably not very often, right? And you'll see what I'm talking about in a second. So now, when I look at 12, the square root of 12, I want you, first of all, notice this. I could write this as the square root of, and the first number I write here is going to be one of these numbers. Which of those numbers goes into 12?
4.
Everybody agree with that?
Uh-huh.
So I know that's a perfect square. So I always write my perfect square first. 4 times what?
4 times 3.
Okay, 4 times 3. Okay, everybody there? So now, if I have the square root of 4 times 3, that is the same thing. It's totally legal to do this, separating them as the square root of 4 times the square root of 3. That's totally legal. Those are the same thing. Okay?
So it's 2 times
What's the square root of 4 though?
2.
2. So my final answer is 2 square root of 3. Okay, do you see that? Does that make sense?
This is so much easier.
So
Why-
now-
This is so much harder.
So now, we'll do some of the other ones we did, and then we'll try a different one. Square root of 48. All right,
28.
28. Which of these goes into 28?
The square root of 7.
9. No, wait. 4.
4 is my biggest number. And remember, I am looking ideally for the biggest number, my biggest perfect square that goes in 28. You know, so I know 4 goes into it. I'm going to just check. 4, let's see, 9 times 3 is 27. Oh, shoot. No, so 16 times, oh, that's not going to work. 25! Oh, no, that doesn't work either, right? So 4 is my biggest number that goes into 28. So that's great. So I always put my perfect square first under here. 4 times 7, right? All right, what's this? Okay, so I could break it out like this, right? I could break it out like this, or I can even make another shortcut. What is the square root of 4?
2.
All right, so I cross out the 4 and put a 2 up there, and then it's just the answer is 2 square root of 7,
Okay, that's pretty
right?
Yeah.
Pretty easy, right? It's
Why
getting
did you
easier,
teach us this way?
right? Because I want you to know both methods, because I want you to understand the concept of like the anatomy of a radical sign, so that you understand when it has a 2 there, you're looking for 2 of the same number. When it has a 3 here, you're looking for 3 of the same number. When it has a 4 here, you're looking at 4 of the same numbers, right? And so some people struggle with radicals, but if you're using the tree factoring method, honestly, most people do not struggle with it once you do that. So if you're the type that this is harder for, use the tree factoring method. If you're not, and this makes sense, use this method. There's always more than one way to do anything, right? So how about, let's just try something totally different. How about we do the square root of 50? All right, so we're not going to use the tree method. We're going to use this method. Okay, does 4 go into 50?
No.
No. Does 9 go into 50?
No.
9 times 5 is 45. 9 times 6 is 54. No. Okay, 16. Does 16 go into 50?
No.
No. Does 25 go into 50?
Yeah.
Oh my gosh!
Twice.
So that's the square root of 25 times twice, right? Times 2,
Times twice.
right? So what is the square root of 25?
5.
So I'm going to cross out my 25 and put a 5 up here. And so my final answer, I just bring the 5 down, is 5 square root of 2. Piece of cake, right? Piece of cake.
What happens if you like your number not none of the perfect squares fit in your number?
Ah, okay, great question. Okay, so let's do that. Let's do,
The homework.
actually, let me look at, let me do this one slightly differently, just for a second. Okay, hang on, because I want to answer her question. Look at this. If I did the square root of 12, and so this is really key to understanding this deeply. Okay, if I did the square root of 12 and I said, oh, but that's the same as 2 times 6. The square root of 2 times 6. Awesome. You're right. It is. 2 times 6 is 12. But 2 is not a perfect square, and 6 is not a perfect square.
What?
And so you kind of messed things up, right? You're going to have to keep going. You're going to have to change the 6 into a 2 times 3 before you have an idea of how to move forward.
2 times 3.
But
You have to, if you're going to use this method, it's always got to start with a perfect square. If a perfect square does not go into a number, this is important.
perfect square does go
If
into the number.
If a perfect square does not go into a number other than 1, right, then you cannot simplify the expression. So, for example, the square root of 15, that's a good one. All right, which of these goes into 15? Does 4? 9? None. Therefore, the square root of 15 is simplified, is the square root of 15. There's nothing you can do.
Wait, could you just
The only way you can change the way it looks is if one of those perfect squares goes into here. Okay?
Yay.
Okay.
so you can't change it at all. You can't be like
Right. So now, last one. Last one.
Write down the perfect
Square root.
square.
You just give us the
Square root of 72.
idiot.
Square root of 72.
9 and 8.
Okay.
Wait, 9.
So let's try that.
That's 9 times 8. 9 times 8.
So we want to know, does 4 go into 72?
No.
4 goes in one's 32. Actually, it does.
We
One's
want
18, I think.
Gary, is
Something
it
like that.
best to use the biggest number you can use or the smallest number you can use?
You want the biggest one of these that goes into 72.
Oh, then you can use 36.
Oh my God, right? Look at that. 36 times 2 is
Oh, wow.
72. All right, so if I notice that that's right, look at this. 36 times 2, so square root of 36 is 6. So it's 6 square root of 2. Look at how fast you found the answer. Now, if you did not realize that and you said, oh, well, wait a minute.
9.
What, 9? Yeah, 9 times 8 is 72. So let's say you said 9 times 8. 9 times 8, right? So square root of 9 is
4.
3. Right. So you got 3 times the square root of 8, right? Oh, wait, that's not 6 times the square root of 2.
Yes, because it is because of wait. Never mind.
Wow, Bella.
You can simplify.
I knew it, but it
Eight
Okay.
still has.
Yeah, it still has one more.
Does the square root of 8 still have a perfect square in it?
Yes, it has a 4.
Oh my God. Okay, so I can keep going. I can say 3 square root of 4 times 2. So the square root of 4 is 2. Now it's 2 times 3, so that's 6 square root of 2. Right? So if you mess up and don't choose the largest perfect square, you can still keep going. It's not like you messed it up totally. You can keep going. It's just an extra step. Does that make sense? You guys see that?
Yeah.
Just to 5. Are you guys understanding this?
I don't like the fast one. I like the slow one.
All right, so now what I want to know is, let's vote. I want to know which method you guys like better for my own understanding. So there was the tree factoring method. How many people like the tree factoring method? Okay, 1, 2, 3, 4, 5, 6, 7, 8. All right, how many people like this method? 1, 2, 3, 4, 5, 6, 7, 8. Some of you voted twice. Okay, so it's about even, right? It's like half and half. That's interesting. All right, well that's it. That's it for the lecture for today.